Watershed Management, Rainwater Harvesting, Chapter 14, Part 3, Multilayer Aquifer Recharge. The overexploited aquifers of Dhar block in MP face mounting pressure from both salinity and fluoride contamination. We undertook an ambitious and scientifically grounded rainwater harvesting project in 2018. The chosen site, Khadi village in Badnawar Tehsil, lies within a basaltic terrain marked by fractured zones and intermittent alluvium. CGW's 2013 assessment indicated groundwater development at 121% and highlighted critical recharge depths at 8 to 18 meter, 14 to 20.8 meter, and 37.4 to 48.60 meter. Given this context, our goal was to design a location-specific multi-layer aquifer recharge structure to improve groundwater potential and community access. Our work began with extensive community interaction to understand the local context, existing infrastructure, and perception around water harvesting. We mapped 6 key borewell locations, identifying 3 failed and 2 defunct borewells within the Panchayat campus and nearby sites. Our functional borewell near the roadside yielded 50 to 100 liter per minute at a depth between 30 to 80 meters. Among strategic options, we choose to connect roof water from the Gram Panchayat Bhavan and nearby RO water ATM facility to the failed borewell, enabling recharge through existing infrastructure with minor modifications. The catchment area covered approximately 1750 square feet, including the rooftop of Gram Panchayat building and the ATM structure. Based on MP rainfall pattern and a runoff coefficient of 0.8, we calculated a rainwater harvesting potential of 108,420 liters annually, assuming 90% of the runoff was captured over 90 days of monsoon. Meanwhile, the ATM's daily disposal of 1,600 liters added a continuous source for the recharge. Together, we estimated a recharge target of 2684 liters per day. From a design perspective, the rainwater harvesting structure required a tank volume of 20% of the roof area, leading to a base volume of 350 cubic feet. With a minimum tank height of 9 feet, the required groundwood area came to be around 40 square feet. For multi-layer recharge, we drilled a depth of 300 feet, fitting an outer casing of 40 feet and an inner casing of 200 feet. Slotted casings were provided at 80 to 100 feet, 100 to 120 feet, and 160 to 180 feet, corresponding to the fractured basaltic aquifers mapped through stratigraphic data. The observed water touch points ranged from 70 to 110 feet and extended up to 330 feet in deeper formations. The lithological profile based on drilling logs revealed clay 11 layers ranging from soft black soil to hard massive basalt. Key water-bearing layers corresponded with weathered and vascular basalt zones at a depth between 18.30 and 94.60 meters. Loose stone formations further indicate transmissive zones ideal for recharge. We developed the recharge tank using 5 feet by 8 feet brickwork lined with 4 feet of locally sourced filter media comprising sand, gravel, and pebbles. The borewell was designed with slotted PVC pipe segments aligned with aquifer zones, and a transparent ceramic dome covered the surface tank for visual monitoring and community aesthetics. The total cost of project was 2,25,000 rupees. This included 73,500 rupees for the rainwater harvesting tank component, earth cutting, brickwork, covered slab for the plumbing, filter media, and valves, and rupees 1,02,000 rupees for borewell modifications that includes boring, casing, collars, slotting, and fitting. We also provisioned around 50,000 rupees for expert consultation, technical planning, and field facilitation. Through community meetings, we addressed common concerns whether rainwater harvesting could aid waterlogged areas, improve water quality, or be feasible in limited spaces. These dialogues turned villagers into stakeholders. The case demonstrates a model of roof water harvesting connected to multi-layer recharge. It affirms the significance of integrating geology, hydrology, and community ownership. By carefully aligning rainwater availability, aquifer depth, and cost-effective infrastructure, we can create a living demonstration of water resilience in one of the country's most stressed zones. Thank you.